All right, Mr. Trutna here. Just changing my settings a little bit. Hi, guys. We're going to go over the Unit 3 assignment number 2 notes. Tree diagram was done in class. Let's go over multiplying a binomial times a binomial and multiplying a binomial times a trinomial. Okay? First of all, let's do a couple of definitions here so we understand what a binomial and a trinomial is. A binomial is an algebraic expression with two terms separated by a plus or minus symbol. Trinomial is an algebraic expression with three different terms separated by a plus symbol or minus symbol. Okay? Multiplying a binomial times a binomial. An example would be the binomial 3x plus 2. Notice that is an algebraic expression. It's got two different terms, 3x and 2. Those are separated by an addition symbol or a plus symbol. Multiplied with 4x minus 6. That is also a binomial. The way that we multiply these two binomials is we incorporate the concept of the area model. Okay, so we are going to draw a square or a rectangle, it does not matter. We're going to write the first binomial or the first expression along the top, put the 3x, put the plus, and put the 2. At the addition symbol, draw a line dividing the rectangle or the area model into two pieces vertically. Along the side of the area model, write the second expression, the 4x and the minus 6. And because there's two expressions, we are going to divide that area model in half horizontally. So we create four individual rectangles, and then we're always going to fill in the inside of each individual rectangles by always multiplying the top with the side. So this top left rectangle, we're going to multiply 3x with 4x. That becomes 12x squared. So the area of the top left rectangle is 12x squared. In the top right rectangle, we're going to multiply the positive 2 with the 4x. That result is 8x. In the bottom left rectangle, we're going to multiply the 3x with the negative 6. That is negative 18x. And for the bottom right rectangle, we're going to multiply the 2, the positive 2, with the negative 6. That is negative 12. So that means that 3x plus 2 multiplied with 4x minus 6 is equal to 12x squared plus 8x minus 18x minus 12. And that would be my answer to what 3x plus 2 multiplied with 4x minus 6 is equal to, if this cannot be simplified. But you hopefully can see that you could combine the minus 8x with the positive 8x with the minus 18x. So this would give me 12x squared minus 10x minus 12. That is what the result of multiplying the expression 3x plus 2 with the expression 4x minus 6 is. Okay, the next example, multiplying a binomial times a trinomial. So here's an example of that. Let's say we have the binomial x plus 1. And then we're going to multiply it with the trinomial 3x squared minus 7x plus 8. So notice we have a binomial x plus 1, two different terms separated by the addition symbol. Then we have a trinomial, 3x squared is different from 7x, which is different from 8, three different terms, each different term separated by a subtraction or an addition symbol. The way that we're going to multiply these is we are going to incorporate the area model, just like we did when we multiplied the binomial times the binomial. This area model is going to have a few more parts in it, so we're going to take the x plus 1, we're going to write that along the top, x plus 1. Because there's two different terms, I'm going to divide the area model into two pieces vertically. Along the side, I'm going to write the trinomial, 3x squared minus 7x plus 8. And because there's three different terms, I'm going to divide the area model into three pieces horizontally. So then I have to fill out the inside region of all 6 rectangles, always multiplying the top of the rectangle with the side of the rectangle. So the top left rectangle, I would multiply x with 3x squared. That is 3x to the third power. The top right rectangle, I would multiply the positive 1 with the 3x squared. That is 3x squared. The middle left rectangle, I would multiply x with negative 7x. That is negative 7x squared. The middle right rectangle, I would multiply the positive 1 with the negative 7x. That is negative 7x. The bottom left rectangle, I would multiply x with positive 8. That is positive 8x, or just 8x. And the bottom right rectangle, I would multiply positive 1 with positive 8, which is positive 8. So that means that the binomial x plus 1 multiplied with the trinomial 3x squared minus 7x plus 8 would be the combination of all 6 of these rectangles. 3x to the third plus 3x to the second minus 7x to the second minus 7x plus 8x plus 8. And that would be your answer if there was nothing that we can combine. But you can see I can combine the 3x squared, the positive 3x squared, with the minus 7x squared. I can combine the minus 7x with the positive 8x. So that gives me a final solution of 3x to the third power minus 4x to the second power plus x minus 7x plus 8x is positive 1x. I just put plus x plus 8. There is my solution. Or that is what the binomial x plus 1 multiplied with the trinomial 3x squared minus 7x plus 8 equals. Okay? All right. The next part, which is a review for us, are two triangles similar? How can you tell? So remember, 3 ways to show two triangles are similar. There's the AA rule, the SSS rule, the SAS rule. Okay? These are the 3 ways that you show that two triangles are similar. Let me give you an example of each one. First of all, the AA rule. AA stands for you're going to have two triangles. They will be similar to each other if there are 2 pairs of equal angles in the 2 triangles. 70 degrees and 70 degrees. They do not have to be in the exact same spot as long as there are 2 pairs of congruent triangles. 35 degrees and 75 degrees. Notice that 70 degrees and 70 degrees gives me one pair of congruent angles. And then notice by doing a little bit of math, 70 plus 35 is equal to 105. And then 105 take away from 180 gives me 75. So in this bigger triangle, that bottom right angle has to be 75 degrees. So that means I have a 75 degree angle and a 75 degree angle. Notice, two pairs of congruent angles are congruent. These triangles would be similar by the angle or the AA rule. The next rule is the SSS rule, side, side, side rule. And the side, side, side rule says that one triangle will be similar to another triangle as long as you have information about all three sides of the triangle, like 5, 7, and 8, and all of the sides that correspond, their ratios are equal. Okay, so you have to have information about all three sides of the triangle, and then their ratios have to correspond. So if you notice, the shortest side in the small triangle, 5, would have to correspond with 15, because that's the shortest side of the bigger triangle. That would give me a ratio of 5 over 15, which reduces down to 1/3. Okay, the longest side of the smaller triangle, which is 8, would have to correspond with 24, because that's the longest side of the bigger triangle. That would give me a ratio of 8 over 24, which reduces down to 1/3. Okay, so the 5 over 15, which was 1/3, the 8 over 24, which is 1/3, that gave me a pair of congruent sides that have the same ratio as the other pair of sides, but I got to have 3. So notice the 7 has to correspond with the 21, so that would give me a ratio of 7 over 21, which reduces down to 1/3. So side, side, side. You have to have information about 3 of the sides, and all the ratios have to reduce down to the same amount. They have to be equal to one another. And if they are, the triangles would be similar by the side, side, side rule. Okay. The third rule is the side angle side rule. The side angle side rule says that two triangles will be similar to each other as long as they have one pair of congruent angles, 20 degrees and 20 degrees. Notice there's one pair of congruent angles, and you have to have information about 2 of the 3 sides of the triangle, 6 and 10, and the angle has to be included in between the 2 sides. 24 and 40. Okay, and then for side angle side to work, the ratios of the sides have to reduce down to the same amount. They have to be equal. So notice the 6 in the small triangle would correspond with the 24 in the big triangle. That would give me a ratio of 6 over 24, which reduces down to 1/4. The 10 in the small triangle would correspond with the 40 in the big triangle. That would give me a ratio of 10 over 40, which reduces down to 1/4. And notice that the ratios 6 over 24 is equal to the ratio 10 over 40. And those come from the sides that are, and the angle is in between. So I have side, pair of angles that are equal, and side.